Hello everyone. Tonight we are working on Module 4, Lesson 6, and we have been thinking about fractions as division for the last several days, and we're going to relate that thinking of fractions as division to thinking about fractions of a set. Let's start off by thinking about 1/3 of 6. I have a set, and there are 6 in the set. That's what I mean when I use the word set. It's a group of objects. And when I say I want 1/3, that means I'm going to take my group of objects and I'm going to split it into smaller groups. Right now I'm going to show that by making a line so that now I have 1, 2, 3 groups, and that corresponds to my denominator of 3. And I can also see that I have 2 disks in each of my groups. So there are several ways to think about this. The most obvious way is to think about it as a division problem, which would be 6, because my whole set had 6 in it, and I divided it into 3 equal groups, and there are 2 circles in each group. Another way I could think about it, since I have 1/3 of 6, which is the same as 1/3 times 6, and as we talked about in class today, that means that I'm adding 1/3 together 6 times, so I'm going to end up with 6/3. So 1/3 of 6 is going to be 6/3, which of course is the same thing as 6 divided by 3. And that is also going to equal 2. Let's take a look at 2/3 of 6 this time. I am still going to draw 2 lines to divide my set of 6 into 3 equal groups. So my denominator is 3, and I have 1, 2, 3 equal groups. And as you can see, we still have 2 in each group. But since now my denominator says that I want 2/3, that means that I'm going to look at the number of circles in 2 groups. And I've got 2 in the first group, 2 in the second group, to make a total of 4. So that means that 2/3 of 6 equals 4. So what I did here was almost the same thing that I did last time. I divided 6 by 3, and that equals 2, which was the number in each. That gave me the number of circles in each group. But since I am not using a unit fraction this time, remember when we practiced this morning, we always used unit fractions and we multiplied by 1. But since this is not 1, I have to multiply my answer from my division times the numerator, which is 2, and so my total will be 4. And the reason for that, the reason I have to do this extra step, is because that numerator being 2 means that I want 2 groups of my set added together. Okay, let's see if we can apply what we've learned to a story problem. Mrs. Pham has 8 apples. She wants to give 3/4 of the apples to her students. How many apples will her students get? Now, one thing that I would like you to be aware of when we're making diagrams is thinking strategically about the numbers that you've got. I've got a set of 8, so I'm going to bring out my 8 circles. Okay, and I could have just 8 random circles. Whoops, laying around. It's kind of hard to divide a set like this up into groups. So I want to make an array of my 8 circles that represent the apples. And I'm taking a look at my story problem, and I see that I need 4 groups. So I'm going to arrange my my circles so it's easy to divide them into 4 groups. In other words, I'm going to make an array of 4 times 2. So 1, 2, 3, 4, 1, 2, 3, 4. Okay? And so I've got my 8 apples here represented by 8 pink circles. I know that I need 4 groups because my denominator is 4, so I will draw some lines to show that I have 1, 2, 3, 4 groups now. And I'm going to take a look at how many are in each group. And of course there are 2 apples in each group. However, she wants to give 3/4 of the apples to her student. That means that she wants to give 3 out of the 4 groups to her students. She's only keeping 1 group for herself. And if I count the number of apples in each group, that would be 2, 4, 6. So the answer is she will give 6 apples to her, ran out of room, students. Okay? So you're going to do an applied problem, and then I'll see you in class tomorrow. We'll see how you all did. Good luck.